Deep in the heart of Guiyang, the capital of Guizhou province in southwestern China, a city of 5 million sites inside a basin ringed by karst mountains on every side. Every valley is occupied, every road is full, a beautiful nightmare for urban engineers. To push a new expressway through the center of the city without demolishing the 40-story commercial tower already rising directly in its path, engineers plan something that has never been attempted at this scale anywhere in the world. The road will pass through the building. Not under it, not beside it. Through its lower floors at the 6th, 7th, and 8th levels, while the tower above continues to rise and the city below continues to move. This is the Guiyang Urban Expressway at the Longxi International Center. In 2012, the mobilization began. Survey crews moved into the Guanshanhu district and mapped every structural element across 3 city blocks. The decision was locked immediately. The building and the highway are designed as one integrated structure from the first drawing. Over 600 machines were summoned to the site. An army of 4,000 workers arrived in January 2013. The first piling rig broke ground on February 8th. The foundation must carry 2 load types that work against each other. Building columns drive weight straight down into bedrock. Highway traffic drives dynamic loads horizontally through the same frame at speed, with heavy trucks producing repeated impact loads at the rate of thousands per hour. These forces travel in different directions. They arrive at different frequencies. A standard high-rise foundation handles one. A highway bridge foundation handles the other. This foundation handles both at every point where the 2 structures share a column. Drilling rigs bore into the limestone below the clay layers. Thousands of tons of steel rebar are lowered into each shaft. Concrete is pumped to the base of every pile, filling upward until the pour reaches ground level. Each pile is tested under load before the cap is sealed. Piles that fail to reach the required bearing are drilled deeper and retested. There's no room for error. The foundation is complete. Building columns go up first. Steel erection crews mark the column grid and lift vertical steel sections into position 1 floor at a time. Each column in the highway zone is fabricated from welded steel plate, not poured concrete, because steel can be positioned to tolerances that cast concrete cannot meet and can be adjusted on site if a measurement reveals a discrepancy. Workers guide each section into position using tag lines from the ground, while the crane holds the load above. Connection bolts are driven home at every floor level before the crane releases. Every joint is torqued before the load transfers. The columns climb floor by floor. By the 6th floor, the spacing between columns is verified against the highway alignment 3 separate times using total station survey equipment. The highway will pass between them. The gap between column face and highway deck edge is measured in centimeters. Every measurement is logged. The work continues around the clock. At ground level, highway approach ramps begin climbing on both sides of the building simultaneously. On the eastern side, the ramp rises at a gradient steep enough to reach the 6th floor in the space of 2 city blocks. Falsework towers rise along the ramp alignment. Steel frames bolted to concrete footings designed to carry the full weight of wet concrete plus all construction equipment above. Rebar crews walk the formwork, tying reinforcement cages for each deck span. Trucks deliver loads from the batching plant. Pours happen in sequence from the ground upward, each section curing before the falsework strips and repositions ahead. Month by month, the ramps extend toward the building on both sides. The stage is set for the critical lift. Inside the building zone, the highway deck cannot be built on falsework. No access exists between the columns to place or remove towers after the pour. The deck sections must arrive complete and go directly to their final position. Workers pre-assemble each steel deck section flat on the ground, fully welded and inspected before any lift begins. Ultrasonic testing crews walk every weld. Strand jacks mounted on the building structure above take the load on 4 cables simultaneously, 1 at each corner. A single operator watches a level indicator from the ground and controls the jacks. Workers on the 6th floor level stand ready as each section rises between the columns. The section enters the gap, still moving upward at slow, steady speed. Connection flanges align with receiver plates on the columns. The section stops. Workers drive the connection bolts home by hand before the cables release. Precision is key. Each section must land within 10 millimeters of its design position. Every lift is measured before the cables unload. The deck is in place. Concrete is pumped from ground level through a pipeline running up the outside of the building to the pour location. Pump operators at the base control the flow rate. Workers at the 6th floor distribute the mix and drive vibrators through it in a defined pattern. Compaction removes air pockets. Air pockets weaken a deck under repeated vehicle impact. Every section is vibrated before the surface is screeded flat. The deck cures under burlap and water for 7 days. The clock never stops. Workers on suspended platforms below the deck move along the column faces, drilling anchor holes, inserting threaded rods, and torquing connection plates to the specified load. Fearless workers in harnesses reach across the gap between platform and column face, drilling and bolting every connection in sequence. Every bolt gets a paint pen mark after torquing. Inspectors walk the full line every shift. No connection is left unchecked. The skeleton of the passage fills in beam by beam. Each steel beam is lifted from its delivery point at ground level, swung over the building perimeter, and lowered between the columns. Steel workers on platforms at the 6th floor level guide each beam into its seat. Connection plates align. Bolts go in to hold position. Welders follow. The arc burns bright in the enclosed space. Every weld is inspected before the next beam arrives. The skeleton of the highway passage fills in span by span. The walls go up on both sides. These walls are the skeleton of the passage. They carry building load from the floors, above down into the highway structure below. They seal the road zone from the commercial floors on each side. They form the fire barrier between vehicles and occupied space. Formwork crews build each wall in lifts, stripping and repositioning upward as each pour cures. Wall by wall, the passage takes shape. The rough work is done. The precision work begins. The tower crane runs 2 programs simultaneously, highway deck lifts and floor-by-floor tower construction, sequenced to avoid conflicts. When deck sections are in the air, all other operations stop, and the zone below clears. Each lift takes between 40 and 90 minutes. Wind above 25 kilometers per hour stops the operation. Above the highway, the tower climbs on a jump form system. Hydraulic jacks lift the core formwork to the next level after each pour cures. The core walls climb first. Floor slabs follow, poured from the core outward. Curtain wall panels rise, floor by floor, each sealed at its joints before the row above installs. Workers move upward with the building, always 2 floors behind the structure crews above them. The tower grows continuously while the highway structure below it is finished and tested. Both operations share the same site, the same cranes, the same delivery routes. Neither stops for the other. Progress is measured in meters. 3 months before the highway connects to the eastern approach ramp, a section of false work shifts during a concrete pour. The pour stops immediately. Survey crews find that one tower base has settled 6 centimeters overnight, after 3 days of heavy rain soaked the ground below its footing. The fresh concrete in the forms above is hardening. Once it reaches full strength, it locks the ramp geometry into a position that does not match the building entry point. We have hours, not days, to correct the alignment before the concrete sets permanently. Hydraulic rams go between the false work frame and the underside of the deck. Workers jack the ramp section back to its correct elevation, while the concrete is still green. The settled base is excavated by hand. A new pad is poured and cured overnight with the rams holding position. The pour resumes the following morning once the tower is confirmed stable and the alignment is resurveyed. The deck surface matches the design grade. The ramp is won. The connection holds. Cheering. Finishing crews move in. Road marking teams paint lane lines and direction arrows on the highway surface inside the building. Lighting contractors install tunnel lights at the ceiling of the passage. Building services teams run fire suppression pipework through the wall cavities. The final expansion joint is bolted into position. Road surface levels are checked with a precision level across every transition from ramp to deck to building and back to ramp. Every level matches. On September 29, 2016, the Guiyang Urban Expressway opened to traffic through the Longxi International Center. The construction army began to pack up. The machines that had worked inside the city block for 3 years were heading home. Silence fell over the lower floors. Then the first vehicles entered the eastern ramp. They drove through the 6th, 7th, and 8th floors of a 40-story building. They emerged on the western side and rejoined the ground-level street network below. Traffic engineers monitored ventilation readings, deck deflection sensors, and noise levels on the occupied floors above during the first hours. All readings were within design parameters. The building opened for commercial occupancy the same day. Tenants began moving into spaces on the floors above and below the highway level. The building filled. The road stayed open. Residents in the tower's upper floors use the same lobby and elevator core as they would in any conventional office building. They do not feel the traffic moving 6 floors beneath them in normal conditions. Structural isolation between the highway frame and the building frame, achieved through designed flexibility in the connection system at the 6th floor interface, prevents the vibration from truck traffic on the highway from transmitting into the building structure above. The highway carries 40,000 vehicles per day. The building above is fully occupied. The road below never stops. A journey across Guanshanhu district that once required 12 traffic signal stops now takes 4 minutes. Pilots approaching the city see the building with a road running through its middle from the air. From the street below, visitors look up and watch cars cross a bridge that is also a floor inside a skyscraper. No city has ever built this before. A testament to what engineers build when the city has no empty ground left and the brief says, put the road somewhere. Where there was once a blocked city block, now there's both a tower and a road. This is the Longxi International Center, an engineering marvel in a city that had no room left. If projects like this move you, subscribe so you never miss the next one. Drop a comment and tell us where in the world you are watching from right now. The road surface inside the passage receives its final layers in sequence. First, the base course, compacted aggregate rolled in lifts until the density meter confirms full compaction. Then the binder course, a coarser asphalt mix that carries the structural load. Then the wearing course, the surface the tires contact, mixed to resist the heat and abrasion of 40,000 vehicles a day. Rollers work in echelon inside the passage to produce a seamless surface. The heat from the freshly laid material fills the enclosed space. Workers in high-visibility vests move alongside the machines, checking the surface level with straight edges. Rolling the surface while it is still hot is critical. A black ribbon stretches across the passage floor from the eastern entry to the western exit. The structural monitoring system embedded in the highway deck and building columns transmits data to a monitoring center on the ground floor of the building. Thousands of strain gauges, displacement sensors, and temperature sensors report every 60 seconds. The monitoring team reviews trend data weekly, looking for patterns that indicate long-term behavior diverging from the design prediction. In the first 7 years of operation, the structure has performed within all predicted parameters. The concrete deck shows no cracking. The expansion joints at both ends of the passage function correctly through the full range of seasonal temperature variation. The building columns show no differential settlement. The design is performing as calculated. The ventilation system that serves the highway passage inside the building moves enough air to clear vehicle exhaust to safe concentrations under the worst-case condition of slow-moving stop-start traffic through the passage at the peak congestion hour. Exhaust fan units in plant rooms on the upper floors of the building pull contaminated air up through vertical shafts in the building structure to roof-level outlets 40 stories above the road surface. Fresh air enters through openings at both ends of the passage. The ventilation system runs continuously, not on demand, because the occupancy of the passage by vehicles cannot be predicted precisely enough to use a demand control strategy. The air quality in the floors above the highway level is measured continuously. It has never exceeded acceptable thresholds. The residents of the upper floors breathe the same quality of air as the occupants of a conventional office tower on a busy urban street. The building above the highway is a normal commercial building in every operational respect. The tenants on the upper floors do not think about the highway below them during their working day. The sound from 40,000 vehicles a day is not audible in the occupied floors above because the structural isolation system that protects the upper building from vibration also acts as an acoustic barrier. The tenants know from their building materials pack that there is a highway in the lower floors of their building. Most of them have never gone down to look at it. The highway is in the building. The building is in the city. Both are doing what they were built to do. The Longxi International Center changed how Guiyang's engineers and planners think about the relationship between building structure and transport infrastructure. Before this project, the assumption was that roads and buildings occupy separate volumes. Roads go between buildings. Buildings go beside roads. The Longxi project proved that a single structure can be both simultaneously. The integrated design approach that made this possible, designing the building and the highway together from the foundation up as a single structural system, rather than trying to thread one through the other after the fact, is now being applied to other projects in cities where infrastructure and development compete for the same limited space. The lesson from Guiyang is not unusual. The lesson is that the right time to solve the problem is before either structure is started, not after one of them is already rising. The approach ramps on both sides of the building were widened in 2021 to accommodate increased traffic volumes. The widening required modifying the falsework system and adding lanes to the elevated deck, while keeping the existing lanes operational during construction. Nighttime lane closures allowed the widening work to proceed over 8 months without disrupting daytime traffic. The structural connections between the new deck extensions and the original deck were made through the same bolted flange system used in the original construction. The junction between the widened ramps and the fixed highway passage inside the building required careful geometric coordination to maintain lane continuity through the transition. The widening was completed on schedule without any permanent lane closure during the construction period. The expressway capacity increased by 35%. The Guiyang Urban Expressway now carries more than 40,000 vehicles daily through the Longxi International Center. The building above is fully occupied on every floor. The road below runs 24 hours a day. The city around them is denser and more congested than it was when the project was designed. The road through the building is one of the reasons it can still move.